The first microscope was invented in the 16th century. Anton van Leeuwenhoek is considered the father of microscopy for his advancements in the field during the 17th century. Compound microscopes use multiple lenses to magnify objects. Electron microscopes can magnify objects up to 50 million times. Microscopes help discover cells, which led to the development of cell theory. The word microscope originates from Greek words meaning small and to look at. Modern microscopes use software to analyze samples and produce 3D images. Phase contrast microscopy makes transparent samples more visible without staining. Fluorescence microscopy uses specific wavelengths of light to highlight certain features in samples. Scanning probe microscopes can visualize individual atoms. Microscopy is crucial in fields like biology, geology, and materials science. DEM's transmission electron microscopes shoot electrons through samples to produce images. Microscopes revolutionized medicine by identifying pathogens in diseases. Microscopes in forensics can help analyze trace evidence in crime scenes. X-ray microscopes allow scientists to look inside cells and tissues without cutting them. Dark field microscopy uses scattered light to visualize transparent specimens. Super-resolution microscopy breaks the diffraction limit of light, providing ultra-detailed images. Water immersion lenses use a drop of water to increase magnification. Microscope slides were traditionally made of glass, but now come in various materials. Polarizing microscopes reveal details by utilizing polarized lights. Microscopy has advanced with the use of quantum dots for imaging. Stereo microscopes provide a 3D view of samples, unlike most other types. Digital microscopes don't use eyepieces, displaying images directly on a screen. The first portable microscope was developed in the 18th century. Confocal microscopes use laser light to produce sharp, clear images of thick specimens. Atomic force microscopes measure forces between a probe tip and the specimen surface. The highest resolution microscopes are nearing the atomic scale. Inverted microscopes allow for viewing samples from below, often used for cell cultures. Raman microscopy is used to analyze vibrational, rotational, and other low-frequency modes in a system. Live cells can be observed for hours using certain microscopy techniques. Handheld microscopes are popular for field research due to their portability. Bacteria were first observed using microscopes by Anton van Leeuwenhoek in the 1670s. SEMS, scanning electron microscopes, produce images by scanning the sample with a focused electron beam. Cryo-electron microscopy flash freezes samples to study their structures in native states. The limit of optical microscopy is around 200 nanometers due to light diffraction. Endoscope devices are essentially long, flexible microscopes for internal body examination. Fourier transform infrared microscopy analyzes samples based on their absorption of infrared light. No-masking microscopy enhances contrast in unstained, transparent specimens. Tunable microscopes can adjust the wavelength of illumination for specific imaging tasks. Mobile phone cameras have been modified into portable digital microscopes. Microscopes in the 1600s had a magnification of only about 30x, unlike today's high-power ones. Adaptive optics in microscopes correct distortions introduced by the atmosphere or living tissues. Mirror-based microscopes use curved mirrors instead of lenses to magnify samples. Some microscopes use sound waves, not light, for imaging. Focused ion beam microscopes utilize a beam of ions to study materials at the nanoscale. Light sheet microscopy illuminates a thin slice of a specimen, allowing for 3D imaging over time. Turf microscopy uses an evanescent wave for studying surface interactions on cell membranes. Virtual microscopy digitizes physical specimens and views them via software. The micrograph is the term for a photograph taken through a microscope. Spinning disc confocal microscopes use multiple pinholes on a rotating disc to achieve faster, real-time imaging of live cells.